strange rocks orbit our star, the Sun. Planet Earth sits in the path of these rocks, known as asteroids. Every day, on average, 230 of them burn up as they enter our atmosphere. Small asteroids are harmless, but bigger ones could pose a threat. To find out if they're friends or foes of humanity, space agencies are currently sending probes. In order to learn more about an asteroid called Ryugu, the Japanese space agency, JAXA, sent Hayabusa2 across the vast expanses of the solar system. A kilometer wide, half as dense as concrete, Ryugu is a large near-Earth object, a potential hazard to our planet. But it's also close enough to study and test the latest technology. Here's how it creates the perfect crater on an asteroid. It's an audacious plan, seemingly impossible. Launch a spacecraft to a nearby asteroid 180 million miles away. Land safely on top. Take samples and return unharmed to Earth with a souvenir from space. And the Hayabusa2 spacecraft just came one step closer to completing that plan on July 11th by attempting their second and final asteroid sample collection. The mission is now in its final stretch. After a 3.5-year journey through space, on June 27, 2018, Hayabusa2 arrived at its destination, Ryugu. The carbon-rich asteroid orbits the Sun between Earth and Mars. And this primordial near-Earth object could one day unravel the clues of our early solar system. Before arriving, scientists thought that Ryugu's surface would be flat and featureless, perfect for landing the probe and sampling its material. Instead, it soon became apparent that Ryugu is littered with large hazardous boulders, disrupting years of meticulous planning and putting the mission's fate into jeopardy. An initial 2 rovers, cell phone-sized robotic wonders, measuring roughly 7 inches by 3 inches and weighing less than 2.5 pounds, were deployed on Ryugu to great success. In Ryugu's low gravity, these rovers hopped from location to location, floating for up to 15 minutes per bounce, all the while snapping the first detailed images of the asteroid's rocky surface. Shortly thereafter, Mascot, the first of Hayabusa2's larger tumbling rovers, landed on the asteroid's southern hemisphere and compiled data on Ryugu's gravitational and magnetic fields, as well as images to help select the best sampling sites. And what engineers saw changed everything. Hayabusa2's sampling instrument was designed to pierce what was thought to be a soft surface. Instead, engineers back in Japan now had to test whether or not the instrument would be able to effectively pierce the rocky terrain to get the important subsurface sample. While the instrument appeared to work in the lab, Ryugu may not be so forgiving. On February 21st, 2019, mission members held their breath as the spacecraft descended 20 kilometers toward the surface. The procedure required extreme navigational precision. One wrong step could lead to a mission-ending catastrophe. The moment of truth was finally at hand. Hayabusa2 successfully dove to the surface and collected its first sample. With its payload securely in place, it was now time to plan an unprecedented grand finale, blowing up part of the asteroid to collect an untouched subsurface sample. The risky maneuver, performed on April 5th, seems to have been pulled right from a science fiction movie. Here's how JAXA created the perfect crater on an asteroid. First, the spacecraft released a small explosive charge, a single-shot, free-flying gun, as well as a remote camera, before positioning itself a safe distance from the targeted explosion site. Once the camera gave the all-clear, it fired a copper plate. Though it's completely flat, the blast melts it into a bell shape within a half a second, creating a 2-meter-wide crater upon impact, taking Hayabusa2 one step closer to its next challenge. With the spacecraft tucked away from harmful debris, scientists back on Earth now had to double-check whether or not it was safe enough for the probe to descend for its final sample. To find a safe landing site amidst the dangerously high boulders on Ryugu's surface, Hayabusa2 began the first of 4 low-altitude imaging descents over the crater site a few weeks after the explosion. After creating a 3-dimensional topographical map of the surrounding area, a touchdown site is selected 65 feet away from the impact crater, close enough for ejecta from the violent explosion to be found there. It also deployed a reflective target marker to assist the probe as it navigates towards its new sampling landing site. Hayabusa2 then waited until today for the dust to settle, to begin its second and final descent to the surface, before collecting the first ever subsurface material from an asteroid. Mission accomplished. Hayabusa2 became the first space probe to gather samples from multiple locations, as well as the first to retrieve samples from below an asteroid's surface. These rocks and debris were at one time safely hidden from the sun's radiation, as well as space weather, giving scientists a first-hand look at what could be the building blocks of our universe. While the main aspects of Hayabusa2's mission are now complete, the spacecraft will continue to orbit Ryugu for a few more months, releasing its second and final mascot rover on the asteroid. Before the end of the year, it will then fire up its ion propulsion thrusters and begin its journey back to Earth with its precious cargo. At close proximity, Hayabusa2 will jettison the samples through the atmosphere towards the Australian outback, arriving safely by 2020.